Ladies and gentlemen, welcome to the 14th International UFO Congress Convention. We are about to bring on our first speaker, Dr. Tom Van Flandren. A couple of things about Tom. He's a family man. He has a wife and 4 kids. I think his biggest accomplishment of all that he's been married for 42 years. I know that, yeah. Oh, yeah. And that is a accomplishment in these times. He has 4 grown kids. He loves computers. He loves presentations, sharing the wonderful knowledge that he has gained. He is very conscious and interested in health, biochemistry, another passion of his. He's a very healthy guy. Talk to him about these issues. He has some answers. But, you know, he's still a kid at heart. He has this wonderment at the world. And what is real? Now, we all know a guy by the name of Richard Hoagland. Yeah. And we all know that Richard Hoagland is a wonderful spokesman for wonderment. He instills that in us. But now, in getting to meet Dr. Tom Van Flandren, we're kind of going to the source of much of that wonderment, directly to the source. Ladies and gentlemen, you are in for a treat. Welcome, Dr. Tom Van Flandren.
Thanks so much. Thank you very much, Bob, and good evening to everyone. Thank you for coming out. I have prepared a presentation that will definitely shake the bugs out of the system, so it should be smooth going for the rest of the speakers after this. We'll see if we can make this all happen. Let's see. My introductory remark is that we are all in a very fortunate position because our humanoid ancestors date back 3.2 million years, judging by the age of the oldest fossils yet found. And in all that time until very recently, the planet Mars was just known as a wandering reddish point of light in the sky. And it wasn't until the invention of the telescope that Galileo first noticed that actually Mars is an orb, a disk with, that changed with the seasons, had polar caps. Later observers noticed dark markings on it, that it was in all respects a world very much like the Earth, orbiting the sun at a greater distance. Of all those generations that have passed before us, ours is the first generation in human history and prehistory that has acquired the capability to send spacecraft to Mars, to land on the planet and explore local areas in depth, and to send orbiters around the planet, mapping the entire surface at low resolution and seeing snippets of the surface at very high resolution. Since no human being living and no human being deceased that communicated with anybody alive has ever before seen anything that's on the surface of Mars, at least to our knowledge, we had no reason to expect that Mars was anything but a cold, dead world. But now we're seeing it close up, and we're the lucky first ones to see that, and boy, has Mars had a lot of surprises for us. The talk tonight will be divided into 2 parts because one can't look at those Mars pictures and even understand, let alone appreciate what one is seeing without some more background about Mars and its significance in the solar system and some things in general about the our neighborhood in the solar system that we need to know to help us understand Mars. So the first part of the talk will deal with background material, and the second part will be almost entirely spacecraft photographs. With that much by way of a preview, I'd like to go to the first slide and open the presentation with an overview slide. There. Okay, this is the hallway into the talk about Mars and the evolving story of the red planet. The first 5 bullet points deal with the first half of this talk up to the intermission. Then we'll have a short break, and then the second half will deal with the amazing photos. The second slide, which is our starting point for discussion, which is the field of gravity. Rumor has it that Simon Newcomb was sitting under an apple tree, and when an apple fell, he started thinking about gravity and what causes gravity, and eventually discovered the first law of gravity. That was supposedly improved on by Einstein because Newton's law, I said Simon, it's Isaac Newton, of course. Newton's law doesn't really explain why there's gravity, why the Earth seems to hold us down, and leads to the saying, what goes up must come down. Why is that? What's the nature and source of gravity? Einstein made a first attempt at an explanation. He said, well, it's the curvature of space-time. He said, visualize space-time as a rubber sheet. And if you put a big mass in the middle of the rubber sheet, it'll make a big dent in it. And then if you bring a little mass along, and that comes over to the side of the big dent, it will tend to roll downhill toward the big mass. And so gravity isn't really a force that attracts things. It's just a curvature of space-time, and things tend to roll downhill. Well, that worked up to a point, but it isn't a very good explanation at all, because the only reason the analogy even works is because we imagine the rubber sheet here on Earth. That's the environment we're used to. And there was gravity already there under the rubber sheet to pull things downhill. If this rubber sheet were out in space, there would be nothing to make the sphere on the side of the hill move at all. In fact, there wouldn't even be a direction you could call down. There are limitations to Einstein's expectations, but here in the beginning of the 21st century, some new ideas have come forward that have been very successful and have possibly taken us to the next step. The new ideas actually date from the mid-18th century French mathematician Lesage. He had a very good idea, which he attributes to even earlier thinkers, about the nature and origin of gravity. He says gravity is probably not something in the Earth that pulls us at all. He said probably the universe is filled with a flux of very tiny particles moving at very high speeds, which we'll call gravitons, and that the gravitons are small enough that they can easily pass entirely through a big body like the Earth or even the Sun without noticing. But once in a while, a graviton will hit some solid matter directly on and be absorbed or reflected. And we see that in the cartoon. What this means is that if there are any two massive bodies in space, and these gravitons are bombarding them from all directions, they will shadow one another from some graviton impacts, because more gravitons hit them on their outside surfaces than their inside surfaces, because they shadow one another from some graviton impacts they would otherwise receive. So the result is they tend to get pushed toward one another by the excess impacts on the outside. Hence, in this vision, gravity is a pushing force, not a pulling force. and hence the name of the new book that describes all these theories by 20 authors. It's called Pushing Gravity. As it applies to Isaac Newton's apple, the apple in the apple tree is being bombarded by gravitons from all directions in space, more or less coming in equally from all directions. However, more of the gravitons hit the apple from above than from below because the Earth blocks so many of them from getting through from below. And the result is the apple falls because of a net graviton wind always blowing down toward the surface of the Earth. Here's a video that shows us immersed in the graviton sea, and if we pull back to a great distance so that the gravitons are nothing but a fog in the background, then any two masses in space shadow each other from some graviton impacts. There are more on the outside than the inside, and so the orbital motion occurs not because the sun pulls on the Earth, but rather because the gravitons push the sun and Earth toward one another, pushing the Earth more than the sun because the sun blocks a lot more gravitons than the Earth does, so it creates a greater imbalance on the Earth than the Earth does on the sun. So that's a simple visualization that's a little easier to understand than Newton's view or Einstein's curved space-time. But it has, if this is right, it has very important implications for the nature of gravity, some of which will be important in this talk. Moreover, the gravitons in the Laplace model must be extremely fast. And it's fortunate that that's the case because actually there have been 6 experiments in history that have purported to say something about the speed of gravity, but it has always been a puzzlement that all 6 tend to indicate that gravity must propagate much faster than the speed of light. And Einstein put forward reasons why that ought not to be possible. But to give you just an example, if we imagine ourselves standing at the center of the Earth, so we're not rotating, but we are orbiting the sun, then from our perspective, the sun appears to be moving through the star background. And since it takes us 1 year to orbit the sun passes through the star background from Aries to Taurus to Gemini and so on, the constellations of the zodiac, and completes a cycle in 1 year. So from our perspective, the sun is moving relative to the background, and the sun's light takes 8 minutes to cover the 93 million miles to get from the sun to the Earth. Light is very fast, 7 times around the Earth in 1 second, but the sun is very far away and it takes the light 8 minutes to get here from there. Well, in that 8 minutes, the sun has moved some distance. Where does the light come from? Answer, simple. It comes from where the sun was 8 minutes ago when that light left and began its journey to the Earth. Next question. Where does the sun's gravity come from? Answer, right where the sun is now, the sun that we won't be able to see until 8 minutes in the future. Gee, that's odd. Light and gravity come from the same source, traveling along the same linear path to the same target body. What could be different to make them seem to come from different directions except their speed? As you know, if something travels at a finite speed, you have to lead it in order to hit the target object, which is why there's an angular difference. Our predecessors in the field of astronomy have known this for a while. They just not known what to do with this fact. Laplace already in the year 1820 estimated that the slowest speed consistent with observations that gravity could possibly be is 10 million times the speed of light, with symbol c. But modern observations are even less tolerant than that. Binary pulsars and other very highly accurate systems in modern astronomy say the speed of gravity can't be less than 20 billion times faster than the speed of light, which is already darn fast. So that answers the students' questions, but what it means for us here tonight is that if gravity goes much faster than light, then Einstein's interpretation of these with respect to the single point that nothing can go faster than light has to give way to Lorentz's alternative view, which was well known in Einstein's time, but is hardly taught anymore, which is that everything else Einstein said is correct, but there is no speed of light limitation, because it's not really space and time that change, but just meter sticks and clocks and mechanical material things that change. And the implication of this is that there can't really be such things as wormholes that allow time travel. But on the upside, it means that any self-respecting advanced civilization, much more advanced than us, is not going to be using something as slow as the electromagnetic spectrum, light, radio waves, or anything of the kind to communicate, because it takes years, centuries, tens of thousands of years to communicate distances across our galaxy. Whereas with gravitons, once you've mastered that technology, you could have virtually instant communications. We'll call them, for no particular reason, subspace communications. And the same applies to interstellar travel. The warp drive scenario is now possible again in physics because going faster than the speed of light does not mean going backwards in time and violating causality. It means that once you have mastered graviton technology, you can develop warp drives and routinely go faster than the speed of light with the ordinary matter. So perhaps there is a galactic conversation going on at this very moment that is just waiting for us to grow smart enough to join it. One of the most important implications, though, is this last one. Because Lesage gravity with the gravitons deposits energy in all the masses that it acts on, these bodies gradually build up energy. That's consistent with observations because the major planets in the solar system actually emit more energy back into space than they take in from the sun. So that answers an observational puzzle. But what happens if something blocks the free flow of energy and the energy just is allowed to accumulate indefinitely? It will, and eventually something has to give and the body will explode catastrophically. We already know that stars explode catastrophically. They're called novas and supernovas. We have only a sample of 9 planets, and none of them has exploded in human lifetimes. But there is reason to believe that that hasn't always been the case, even in our own solar system. And we'll look at some of that evidence in a moment. But it's interesting to note that if any of the 20 authors in this new Lesage gravity book hadn't been there, or if perhaps if they'd been there earlier, we might have had the same situation as if William Tell had arrived on the scene while Newton was waiting for the apple to fall, and it might have been a century before the first law of gravity was discovered. Graviton heating leads to the idea that planets can explode because it affects planets as well as stars and their moons too. And if anything interferes with the free flow of energy absorbed and re-emitted again, then you have this accumulation that eventually has to give way. Before we apply this, we need to one more piece of the puzzle. And again, this comes right from the kind of science that we study at Meta Research. The organization I helped found is run by a 7-member board and has hundreds of members today. We look into everything that deals with puzzles and anomalies in the universe at large. Our area of interest is defined as 40 kilometers and up, and usually we're looking into those things that that mainstream scientists can no longer get funded to look into because there's some conflict with an accepted mainstream paradigm. It used to be that everyone was free to research as they wished, but now that funding has been centralized and the redundancies eliminated, you can't get funding anymore to look into alternatives to the Big Bang, to solar system origin and to the many other puzzles. Meta-research was founded to help deal with that problem. We look into these things. And the one I'd like to mention now is the alternative to the origin of the solar system. The conventional theory is the primeval solar nebula hypothesis, the idea that a big cloud of gas and dust condensed and formed first a central body in the center as the sun, which continued to accrete more matter and contract. And then it began forming other blobs around the sun, which became the planets, and then other blobs in orbit around the planets, which became the moons. That's the conventional theory, but it has some problems. If there is gas and dust in the Earth's orbit that the Earth, you would think, might collide with as it orbited, it can't just stay there waiting for the Earth to come along because if it started at rest, the sun's gravity would simply suck it in. It would fall into the sun. So it too has to be orbiting, and the laws of dynamics are such that if you're in or close to the Earth's orbit, you can never collide with the Earth. You have to librate. There are many examples of that in the solar system, of objects in the orbits of other objects, and if collisions are forbidden, then you always librate. So that means that the Earth can't accrete more matter from nearby objects. It has to accrete them from objects that have rather different orbits, and those tend to have high velocity collisions which are rather destructive rather than accretive. So that doesn't work. The fact that the angular energy of most of the solar system is mostly in the planets instead of the sun is a problem for that theory. The conventional theory also predicts that the impacts that give the planets their spin would be a 50-50 chance whether the planets would spin forward or backward, and the same for the moons. But almost all the spins, except for a couple of marginal cases of little or no spin or marginal tilt over 90 degrees, are all going in the same direction. So almost, again, that's consistent with 98% of all of the angular momentum. It goes in the same direction. And the major moons share the same kind of preferred direction. So these are the problems with the standard theory, but there is an alternative, the fission model. And in this model, as the sun accreted and contracted, the sun spins up faster and faster as any body that is accreting matter from the outside that already has some spin must do. It's like an ice skater. If she goes into a spin and then pulls in her arms, she'll spin faster. If she puts her arms out again, she'll slow down again. The more contracted the matter is, the faster it must spin to maintain the same amount of angular energy. Well, in the fission model, the sun is accreting and contracting, and as it does so, it spins up, and it eventually reaches the point where, as it spins up, instead of just being a spherical body, it will start to get flattened from centrifugal force, and it'll bulge at the equator. The Earth does that but only by about 1 part in 300. The equator bulges on the Earth from the Earth spin. The sun would eventually spin faster than that, and as it spun faster still, its shape would become prolate, football shaped. And if you got spun any faster than that, the centrifugal force would be stronger than gravity, and the ends of the prolate shape would break off, and you would have fission. And if it's a gaseous body, you would fission two nearly identical twin pairs, one on each side, as the two ends broke off. For mathematical reasons, with the weak end breaking off first, one of the ends has about 80% of the mass of the other. They're not identical in mass, but they're very similar. Then tidal evolution would evolve them outward from that mass they fissioned from, and eventually into synchronous orbits. The fission, if it was the first kind of body we can visualize fissioning is a solid body like the Earth, and the Earth has enough cohesive force because it is a solid body that it breaks off on just one side of that spheroid and tends to form singlet moons when it fissions, such as our moon. But if the body is liquid or gaseous, it doesn't have enough strength to avoid that, and it fissions on both sides, and you get one mass being 80% of the other. This leads us, putting these pieces together, it leads us to the topic of when planets explode. And this is an important piece of understanding Mars history, as we'll see. Here is a slide briefly summarizing some of the evidence dealing with the exploded planet hypothesis, evidence that there has been at least one such explosion, perhaps several, in the history of the solar system. The asteroids are tens of thousands of rocky bodies orbiting mostly between Mars and Jupiter in a large gap in the planet spacing that's wide enough for one additional planet. Instead of finding a planet there, astronomers found tens of thousands of minor planets that looked like fragments of a planet or possibly a planet that never formed. But the orbits of those minor planets, or asteroids as they're called, those words mean the same thing, have what's called explosion signatures, statistical properties that indicate that they originated in a single explosion event rather than that they never got together. And we know about these explosion signatures because we've had 3 or 4 cases of rocket casings or other incidents where artificial satellites in Earth orbit have exploded and produced lots and lots of debris. And it was noticed in cataloging all the debris orbits that these signatures emerged, these statistical properties. And then someone noticed, hey, the asteroid belt has these same properties. There are also exposure to cosmic rays hasn't been long enough for them to date back to the beginning of the solar system. Comets and asteroids have similarities that were unexpected by the standard model, but the exploded planet hypothesis said they're basically the same kind of thing. In fact, a new comet trace back directly shows that the most recent relatively minor explosion event occurred 3.2 million years ago. It was apparently a moon-sized body rather than a planet-sized body. When one of these explosions occurs, it sends out a blast wave of dark black material through the solar system. By the time it gets to other planets, the wave is spread out, taking a week or 2 to arrive, but it eventually passes by the planets and coats the surfaces of some of the airless bodies, such as the moons of the other planets. And the orbiting debris from the explosion would gravitationally bind other smaller debris to itself, and so a lot of these fragments or asteroids should be expected to have debris clouds or satellites in orbit around them. How have these characteristics fared? Well, this is Iapetus, one of the major moons of planet Saturn, which has just been re-imaged recently by the Cassini spacecraft. This is an earlier image showing the most unusual property of Iapetus that's been known for a couple of centuries and was imaged by the Galileo spacecraft a number of years ago. And that is that one side of Iapetus is icy bright and the other side is coal black. The gray area here is an area that Galileo could not image, but Cassini now has, and indeed this gray area on both sides is mostly black. So why would a planet be black on one side and white on the other, and why mainly Iapetus? Iapetus is distinct from most of the other moons in that it has an extremely slow rotation. All the other major moons rotate in a matter of hours, days, or weeks, a couple of weeks at most. Iapetus takes 80 days to spin once on its axis. So if a blast wave were going by, it would only be able to coat one side. And indeed, the reflectivity on the side that was facing away from the proposed blast is in some places 10 times greater than the reflectivity of the moon on the blackened side. Here are some new Cassini photographs showing the icy side and the black side. Here's a close-up showing the boundary, the transition region between the black region and the bright region. Of course, the object is rotating, so there is it's not a sharp transition in high resolution. It gradually fades out because some of this it was exposed to the blast full time and some of it only part time. This shows the anomalous bulge at the equator of Iapetus, for which the most probable explanation is the body that made this huge impact. That would have been large enough that it would have fractured the moon, which would have blown apart briefly, but its own gravity would have brought the two hemispheres back together, crashing together, producing a bulge all along the fissure. There is a precedent for that elsewhere in the solar system, the crater Stickney on the moon Phobos, an inner moon of Mars. The exploding planet hypothesis deals well with all the anomalies and mysteries of the solar system, but it isn't fair to claim as prediction successes things that your theory fits that you already knew about before your theory was formulated. So I won't dwell on all the ways that the exploded planet hypothesis helps us understand the solar system today, although I have a book full of evidence about that. But here are the 5 genuine predictions of the exploded planet hypothesis. It predicted satellites of asteroids in 1976 at a time when no astronomer credited that as a possibility. And the first official discovery was in 1992 of an asteroid, of a moon of asteroid Ida. It predicted satellites of comets, and the first of those was discovered when comet Hale-Bopp came by in 1994. It predicted that asteroids that have unstable gravitational fields, such as Eros, which was visited by a spacecraft, because the gravitational fields are unstable, the satellites can't stay in orbit, so they decay, and the whole debris field would decay and would be found on the surface. But again, since it's slow, gradual spirals, they don't impact on the surface. They just come down until they touch something, and then they start rolling and come to a rest on the surface. So the prediction is there would be lots of debris on the surface and identifiable as having come from orbit by roll marks. The prediction that there would be that the water in comets and meteorites would be salt water was confirmed around 1999, and it also predicted for the first time it told us how to predict meteor storms, because it told us something about the nature of comets that was not previously known, namely that the debris fields that produce meteors are actually in orbit around the cometary nucleus and therefore governed by the laws of gravity, instead of being ejected from the nucleus at random times by unpredictable jets, which the mainstream model thought was the case. And using this model led to successful predictions. Just to illustrate these briefly, here is one of the first spacecraft photos sent back to Earth of part of the surface of asteroid Eros, showing a close-up of one crater, and in the crater there was a boulder, and as seen in the inset here where we have enhanced the image leading up to the crater, we see that there is indeed a roll mark that starts out on the plane, goes up to the lip of the crater and down to the boulder. So it's just as predicted, a debris object with a roll mark that had to have been a former satellite. This is a video clip of the asteroid Eros rotating as seen from the spacecraft orbiting it. We can see that it's pockmarked by craters, and at higher resolution we'll see some of these boulders. It also has this huge trough that goes 2/3 of the way around the asteroid. This shows the shape of the asteroid overall and why its gravity field is unstable, because it's shaped more like a peanut than like a sphere. And you can also see the trough, wrapping around about 2/3 of it. Here we see into the trough a little closer, and then finally very much closer. This is the highest resolution view we have. And what lines the trough but zillions of boulders. And correspondingly, there are lots and lots of roll marks on the surface too. And they go out onto the flat parts of the asteroid as well as the downhill parts. So when you're out there in the asteroid belt, you might well ask which one is Eros, and you can always tell that from the map. There's been more than one explosion event, though, and that brings us to the multiple exploded planet idea. There are lots of things that tell us that this has happened more than once in our solar system's history. For example, in the geological record on Earth, there have been 5 occasions of mass extinction events. And as we'll see in a moment, for a global mass extinction, it takes more than one large impact, like the one hypothesized at Chicxulub. There are also several different classes of meteorites with different and incompatible oxygen isotope ratios. Even in the main belt of asteroids, there are 2 major distinct classes of asteroids and a number of minor ones. There's apparently 2 more asteroid belts out beyond Neptune, the so-called trans-Neptunian objects, sometimes called the Kuiper belt. Cosmic ray exposure ages occur in clusters instead of randomly as they'd be expected to if they were from collisions. And the total mass of all comets is too small to account for, say, a major planet explosion. It has to refer to a more recent event. Well, we can put these pieces of evidence together with some specific astronomical puzzles that have been around for a long time, findings that are well known, well documented, but have no credible explanation. And we take this idea that there have been explosions of planets from time to time in our solar system, and we see that, well, let's look at the evidence for the late heavy bombardment. This is a well-known astronomical event that occurred quite early in the solar system's history. It dates from about 3.9 billion years ago. And the origin of the sun dates to about 4.6 billion years ago, so it wasn't that much earlier. This is quoted from an astronomy encyclopedia. It says, this is a description of the late heavy bombardment. A flux of impactors flooded the terrestrial planet region and is preserved in the cratering records of the heavily cratered terrain on each planet. An essential requirement of any explanation is that the impactors be stored somewhere in the solar system until they are suddenly unleashed about 4 gigayears ago. Now, you'll note the careful avoidance of the word explosion in that description. Explosions aren't yet an accepted part of modern astronomy, but how do you meet the requirements of that encyclopedia description without having some kind of a major explosion event? The information goes on to say it may have been preceded by other bombardments and not easily discernible in the cratering record. Indeed, there is evidence that there were 2 such, and that would correspond with the idea that planets form in twin pairs and suffer similar fates within a fraction of a billion years of one another. A plausible explanation for the late heavy bombardment remains something of a mystery. Again, this is quoted from the Astronomy Encyclopedia. In the exploded planet hypothesis, we attribute these to 2 early giant gas giant planets. We've just labeled them A and B to give them some designation so we can talk about them. Much more recently, on the recent end of this, apparently the most recent planet-size explosion is the one we associate with the so-called Cretaceous Tertiary, or KT boundary. That's a geological boundary on Earth. It's when the dinosaurs demised. It occurred 65 million years ago, and it is in present thinking attributed to a giant impact in the Central American area called the Chicxulub crater. It's about 150 kilometers in diameter. But that one crater can't really have global impact. In fact, the maximum distance it can throw debris turns out to be just a couple thousand kilometers. But the KT boundary event, like some of the other mass extinctions, is global. And there are 13 known craters on Earth that have ages that are the same to within their uncertainty. There are hot zones of radioactivity that date from the same epoch. One of the 2 largest incidents of volcanism over a major portion of the Earth emanating from India, called the Deccan Traps, occurred at the same time. There were major changes in the Earth's air and ocean, and if you can picture this, a single global fire. There is an ash layer that covers nearly the entire Earth from that epoch. But the Antarctic was spared, and that is probably because the source was, again, external to the Earth, and the Earth's axis is tilted, so one pole is always hidden from any explosion that would occur. This is an artist's concept of what would have been seen then with the explosion of the planet in the asteroid belt growing in the sky month after month. And as the meteors arrived, they would first, the impacts and the meteors would first heat the Earth greatly, causing the mass extinctions. And then the dust and ash and clouds they would produce that would last for years thereafter would produce a strong nuclear winter that would freeze the surface. Over 70% of all species on Earth that perished. That means 99.99999% of all life, because you're wiping out entire species. So, we're putting together different pieces of the puzzle here to come up with a coherent picture of the early solar system and the solar system today. And we note that, I won't go into the individual evidence here, but this is all in my book. There's a chapter on each of these, that 3 of what we now call the 9 major planets were actually not original planets of the solar system, but are escaped moons. For example, Mercury was originally to Venus the same as our moon is to the Earth, the only significant difference being that Mercury was just large enough in mass that the tidal forces that have been moving our moon away from the Earth over billions of years, our moon's mass raises tides on the Earth, which cause its orbit to spiral. But there is not enough angular energy in the Earth-Moon system because the moon's mass is not quite big enough for the moon to ever escape. Mercury's mass is just above that critical threshold, and the same tidal forces acting on Mercury would cause it to escape, and it would escape, we've shown dynamically, into pretty much the orbit that Mercury has today. And this accounts for its very unusual spin as well, which is, astronomers are hard-pressed to explain with conventional theories. There's evidence, too, that Mars escaped from planet V, and I'll address that in detail. But Mars itself is not one of the original planets. It was originally a moon of a major planet that exploded and formed the inner part of the main asteroid belt, in a planet that was in the orbit that Mars is in now, but there were twin moons of the exploded planet, Mars and another body we call body C, and when the parent planet blew up, the 2 twin bodies were left orbiting one another in the same orbit around the sun. And I'll mention evidence of that in a later slide, because Mars is important to us, and the fact that it's an escaped moon is important for understanding it. Pluto and its moon Charon are another example. These were escaped from Neptune. Neptune's moon system is very disrupted, and Harrington and I were able to show in a paper that Pluto and Charon were originally moons, and they escaped and now orbit one another. They're both still there, and the orbits are stable. So, again, putting these pieces back together, we now see evidence for the 2 giant planets A and B that exploded way back at the beginning of the solar system. We see evidence for intermediate age explosions. We call them T and X, planet X and planet T, which are out beyond Neptune and produce the 2 new asteroid belts out in that area of the solar system. And we see evidence in the inner main asteroid belt for planets V and K that exploded most recently in geological time, K 250 million years ago and V just 65 million years ago, which is the one that has affected Earth history the most in ways that we can still see the evidence. So putting the picture back together, the solar system originally had 12 major planets. Note the emissions of the escaped moons. Venus and Earth, which form twin pairs, V and K, twin pairs, A and B, twin pairs, Jupiter and Saturn, Uranus, Neptune, T and X. And we can see that in the reconstructed solar system, the original masses bear approximately the 80% ratio that would be expected of the twin pairs by these estimates. Now, this may be standing the astronomer's picture of the solar system on its end, which is perhaps turnaround is fair play, because astronomers and physicists are often standing the picture of the world of civilians on its end as we learn new things about the universe around us. And hopefully, as we continue to grow and evolve, we still have some more exciting surprises ahead of us. The same kind of symmetry applies to the moons of the major planets, which also seem to occur in twin pairs with about an 80% mass ratio. So there are about 15 to 18 lines of evidence that Mars was a moon of a major planet when it got started, and up until relatively recent times in terms of astronomical years. I just mentioned 5 points of evidence on this slide. Nothing is more noticeable than that we have discovered since visiting Mars that Mars isn't like one planet all over. It's like two completely different planets, two different hemispheres of planets that have been glued together. One half of Mars is saturated with craters, big craters, all over, and has a crust that's 20 kilometers thick at its thickest place. The other hemisphere of Mars is flat, smooth, and featureless. The crust is 1 kilometer thick almost everywhere, and the absence of cratering anywhere is striking. The pole of Mars tipped suddenly by about 90 degrees. Mars originally had a very dense atmosphere, and that's mostly gone now. And there is evidence on Mars for the isotope of xenon-129, which is a fission byproduct and requires a very energetic explosion rather than natural processes to be present at all. I mentioned the other body that was one of the twin pairs that was left in orbit with Mars and body C co-orbiting each other when planet V exploded. That body apparently exploded 3.2 million years ago and was the origin of the comets that we see today, because the comet traced back as consistent with the body C evidence. And body C, from direct evidence from meteorites that we think were from that object, shows evidence of a large presence of water and oxygen. And so we think that its explosion is what produced the one-time massive flood on the surface of Mars, for which we're seeing so much evidence today, but which is so puzzling because there are lots and lots of outlet channels for the floodwaters, but no inlet channels. No one knows where it came from, but they aren't thinking of coming from above, from the explosion of another nearby world. This mosaic picture shows the two hemispheres of Mars in a rather striking way. You can perhaps see, if you're close enough to the screen, that the cratered side has lots and lots of large craters right up to the hemispheric boundary, and that the blue, which is the lowlands, the red is the highlands, the flat blue lowlands, you can hardly see a crater, but for a small one here or there. Moreover, this is a picture from the boundary region, and just as at Iapetus, when you have an explosion event coating one side of a planet and the other side shielded, the whole edge of the planet that the exploding objects can't just reach but graze past are going to produce features like this, and we see those on Mars near that boundary region. So there are lots of reasons for us to believe that Mars is a former moon. And this will help us to understand some of the things that have been found this is an artist concept of our Spirit lander. Of course, we've now had 5 landers on Mars, 2 Vikings back in 1976, landers, the Pathfinder lander earlier in the last decade, and Spirit and Opportunity that landed there just last year and are still active on the surface. This is a graphic picture taken by one of the landers on the surface, showing a crater on Mars and showing how the interior has been affected by water erosion. This image is on the CD on the label of the CD that contains all the slides of this presentation, if any of you are interested in having some of these slides to show friends and family. This is a picture taken by opportunity of the interior of a crater on the surface of Mars, showing these objects that have been nicknamed blueberries, but they're actually made of hematite, a kind of metal or iron-like substance. But what's interesting is that they're all over the surface of Mars on major portions of one hemisphere. And the only thing we have that's really closely like that in appearance on Earth is, again, at the KT boundary in places where we can access it. The upper picture here is taken at a place at Caravaca, Spain, at the KT boundary, and the lower picture is from Opportunity's rover on Mars. Here's a close-up of one of the spherules. So again, this indicates that Mars may, since these things are all over on one hemisphere, may have been close up to the body that exploded. But there are not just evidences for explosions on Mars. We see other kinds of evidence on Mars too, and this is what you hear least about in the press because it's kind of a hush-hush subject. Is there evidence for more than just geology on Mars? This is something seen in one of the Opportunity craters. Here's a close-up of it. There's been several of these spotted. They look very much like what we call crinoids on Earth. They look like fossils, basically. And fossils implies at least past life on Earth. Of course, there's already a big debate about whether or not there was past life on Earth. This is one of two so-called Mars meteorites. This is the ETA 79001. The one that's mostly been in the news is ALH 84001 from Antarctica, in which many microfossils were found, and it's been argued strenuously that those are indications of past life on Mars, leaving fossils. That also has been soundly attacked, interestingly, mostly by people who have a scientific interest in our not finding life on Mars or evidence for it quite this soon. But there's more evidence than that. The Viking landers in 1976 carried 3 tests for biological activity, and all 3 tests came back positive for biological activity. There wasn't any ambiguity. They came back showing life rather than non-life. But there was one surprise, which is that the test for organic molecules, which is a prerequisite for life as we know it, came back negative. And so, with a sigh of relief, the JPL scientists said, well, it can't be life. It has to be chemistry emulating life. And that maybe Mars will someday evolve life as Earth did because it has the prerequisites. Well, that conjecture was investigated for 20 years by, for one of the principal investigators on the lander experiment, Gilbert Levin, whose labeled release experiment came out with some of the strongest pro-life results. His experiment, he thought, was pretty conclusive in that regard. And he and other investigators tried for 20 years to find a way, way to reproduce the results through chemistry, and did not succeed. Excuse me. So they eventually said, all right, well, we can't do it by chemistry. What about the organic molecules test? Well, they took a sample from Antarctica with a known virus in it and found that using the same instrument here on Earth, it failed the organic molecules test too because the test was simply not sensitive enough to detect bacterial or microbial life. So having answered all of the objections and having all the evidence come back strongly pro-life, Gilbert Levin has now published 3 papers in the peer-reviewed literature in which he says the Viking labeled release experiment detected living organisms in the soil of Mars, period. No qualifiers. But again, it's a story that the mainstream press has been offered to pick up, but they burned so many bridges. Oh, thank you very much. They burned so many bridges with some of the scientists in doing that, that the story is just waiting now for much better evidence, much more compelling evidence than the rather theoretical arguments that have been brought to date. Appearing currently in a current issue of Science magazine is some of the very latest evidence for this. So if you're paying attention to your science news, you'll see that the latest evidence found is the evidence for both methane and formaldehyde on Mars. And these are compounds which have a relatively short half-life, so they would vanish from Mars if they occurred and didn't have a continuous source. They would vanish within a couple hundred years at the outside for even the longest lived of these molecules. So there has to be a continuous source for them to be present in such abundance today. And the only kinds of sources that seem plausible are volcanism and biology. Biology being a well-known active source of both of these compounds. But there are no known active volcanoes on Mars, and the patterns of where these molecules are seen most doesn't agree with where the volcanoes are anyway on Mars. But it does agree very nicely with the biological hypothesis, because in regions where there's lots of melt flow from the melting of the polar caps, we tend to see a lot more of these substances. So again, evidence of not just ancient life on Mars, but living today viral and bacterial organisms in the soil of Mars. That brings us to our first intermission, and I just want, before we go on, and the rest of the talk will deal with the spacecraft images of Mars and their interpretation, but this evidence already shows us that we have plenty of reason to believe that Mars is not the cold, dead world that we expected to find when we first started sending probes there. And you'll be interested in knowing sources of more information on all these things. I mentioned my book a couple of times, Dark Matter, Missing Planets, and New Comets. We publish also a quarterly research bulletin, the Meta Research Bulletin, and members can get a subscription with their membership. We also, I mentioned lots to do with gravity and its role in exploding planets and extraterrestrial communication and all kinds of interesting related things. And the book Pushing Gravity, which is by 20 authors. I also have a small number of copies available. And there are 2 CDs available, one dealing with everything you ever wanted to know about gravity, and one having the Evolving Mars story with all the slides of this presentation. So with that, we'll take a 5-minute break while they change tapes in the back, and so you can stretch your legs, and then we'll go to the slides from the orbiting spacecraft, the high-resolution views of the Martian surface, which has some things in it that you're not going to believe until you go check for yourself that these are really on NASA websites.
Awesome, Tom. Okay, don't go far because we're going to start up again very quickly.
Okay. The spacecraft that we sent to Mars in 1997 is named the Mars Global Surveyor. It went into orbit around the red planet, and as soon as it lowered its altitude, it began surveying the entire planet Mars at low resolution, and also taking some high resolution images whenever it could here and there of special features on the planet. Only a small percentage of the planet can be photographed at high resolution because there's just so much data in a high resolution photograph. But Each pixel in a high-resolution image corresponds to about the size of a person on the planet, about 1.5 meters. So high resolution really means a close-up of the surface, so you can see objects as small as a house or even smaller. The spacecraft went into orbit in 1997 and began returning its first pictures of the surface of Mars in 1998. And let's see, okay, there we are. This is a sample of one of the low-resolution images seen by the Mars Global Surveyor spacecraft flying over the surface of Mars and taking images of the surface. In this low-resolution strip, which is a couple of 100 kilometers across, we see some craters that are perhaps the largest being about 50 kilometers in diameter. There are about 4 of them that are about 20 or more kilometers in diameter. And this one crater has, you can see it's a fairly flat-bottom crater with a steep wall, and that's the shadow of the crater wall, with the sun being over in this direction casting its shadow. On the crater floor, most of it looks like the rest of the Martian terrain, but up in this area of the crater, we see a dark area, sort of like a stain on the floor of the crater. The white box that you see, I should mention before I say what the white box is, that we see similar stains in some of the other craters as well. We'd love to know what those are. Well, the white box shows where the Mars Global Surveyor spacecraft took a high-resolution strip image. These images are taken with the camera pointing down. It opens the shutter. It scans across the surface of Mars as the spacecraft flies by, taking a high-resolution view until the buffer is filled and then shuts off. So this is a typical strip image at high resolution. And it usually can only take one of those every orbit of the planet every 2 hours. Then it has to send it back to Earth and make room for more. So what we're going to do now is look at what the high-resolution image saw, because it started out over the plains of Mars here, went up to the edge of the wall of the crater, down the wall of the crater, started across the flat bottom of the crater, and then into the stained area before it ended. Now, this is the strip image, and this is just the top portion, the very top portion of the strip. And we see that it is relatively flat, featureless, desert sands. No craters to speak of. Well, one tiny one there in the middle. And there's not much to look at. If all of Mars were like this, it would be pretty much a disappointment as a planet. But we're scanning down the image now, the strip image at high resolution. And we're coming closer to the edge of the wall of the crater where we see some debris ejecta from the crater. Here's part of the shadowed wall that's darker. Then we get down to the floor of the crater, which is brighter. And then we go across the floor of the crater and we come to the stained area. No one expected that. And what we see is that there seem to be some dune-like features in white and these black spots that are all over. And the black spots seem to like the sunlight, and they form a strikingly sharp borderline between whatever this is and the rest of the terrain. And we know from examining a lot of photos of these kinds of spots at a lot of different times of the Martian year, that the black spots grow larger in the spring, reach their peak in the summer, fade in the fall, and are sometimes almost invisible in the winter months of Mars. So what are these? They're certainly acting a lot like vegetation, but we see them in a variety of places, especially in polar regions. Here's one that shows the seasonal contrast. spots in midwinter, spots in the springtime where it almost seems as if there's been a melting going on in that area. Here's an area you can see how isolated this is from the rest of the terrain. Lots and lots of spots seen in a magnified view here. The same image. I guess you could call this a Martian pizza pie. This is a different place on Mars that has spots of a different character. Besides spots that change with the seasons, I should mention one other bit of data too. The Europeans have joined the fun of having an orbiter around Mars called Mars Express, and their camera is lower resolution, but it does take pictures in color. And their image of some of these spots shows that when they're at their largest, they are green in color. We see some of these things across the Martian surface too. We call them trails or tracks. What's curious about them is that they're rather straight for natural geological features, and they seem to have these grid-like patterns in the interior. And oddly enough, they seem to avoid cutting craters. They graze along the edge of craters many places, but they don't cut through craters. That's an odd thing for trails to do. But we've seen many other examples. Here's a low-resolution image showing that these trails or tracks can cross hundreds of kilometers across the surface. But for this one track here, we have a high-resolution view that's seen in this white box, and that's the view shown right here. And we couldn't even see at low resolution that there was a crater there, but here again, the trail just grazes the edge of the crater. It doesn't cut through it. And it looks very much like a trench that was carved. If these had been seen on Earth, we'd be tempted to say some large machinery drove through here. Here are some other tracks and trails, and we see now that there's an association between the black spot-like features and the things that look sort of vegetative and the tracks and trails. Well, that's a kind of human characteristic, isn't it? We have lots of roadways that we line with vegetation. But here's a case where one of the tracks and trails splits. Here's a case where there's a right angle turn and then a veer to the left. And again, the vegetation follows. Here's a track or trail, again with more of these grid-like marks in it. And alongside, we'll call it the roadway, are things that look very fractal-like in appearance. They even seem to have branch structure to them. And they do, if you weren't told this was from Mars and were shown this picture, you'd say, well, okay, that's some kind of vegetation. Here's another example. Very spindly these things are at the right season of the year. And they all cast distinct shadows. These are not flat features on the surface. They have considerable height, tens of meters, and they cast shadows on the ground. Here's some more examples. Here in a very frosty area, here in a more temperate latitude. We see lots of structure that's reminiscent to vegetation tending to cluster and get denser in places. The next picture is Arthur C. Clarke's favorite, famous science fiction author. He calls these the Martian trees. We see that there's a central area like a trunk with branching at several levels going out from there radially, and we see shadows cast on the ground. This one would be about 100 meters across, but in the low gravity field of Mars, that isn't as remarkable as it might seem. It must be at least 50 meters high, judging from the height of the shadows. And there's its smaller twin. Here are some of Arthur Clarke's words for attribution. He says, the recent discovery of life in the most improbable places, especially far down inside the Earth's crust, has now convinced me that we have been equally short-sighted. Some of the amazing images from the Mars Global Surveyor, especially the one we just saw, make me 95% sure that there are extensive areas of vegetation or its equivalent on Mars. Now we come to a different kind of feature, and before we go into this, I want to address the issue of natural versus artificial features on Mars and how a scientist tells the difference. And certainly by far the most famous example of an anomaly on Mars where artificiality has been proposed is the so-called face on Mars seen here in this image. This is in a region of Mars called Cydonia, and over here we see some vaguely pyramidal-shaped objects with lots of little mound shapes in the middle. We see other things just off the bottom of the image is something called the D&M Pyramid. I'll have a picture of that again later. There's another mesa here. This whole area has a number of anomalies. This feature with what looks like a triangular area in its interior has been dubbed the fortress. The names are more names to remember features by than they are intended to be suggestions of what they really are. But that one I'll mention again in a moment. And this is the famous face. Now, when this was first seen in 1976, a lot of people laughed and said, ho ho, interesting geological feature. It looks like a face, and some people will probably take it literally, but we've always got nuts in society. There are many people who said that and started talking about face loonies. But there were other people, including some serious scientists, such as the astronomers who first presented this to the American Astronomical Society in 1981, DePietro and Molinar, who said, there's a little too much here to dismiss this as an accident. It could be an accident of geology, but there's enough here that we shouldn't miss the possibility that this just might be something significant. And between them and a group of 30 independent scientists known as the Society for Planetary SETI Research, SPSR, Society for Planetary SETI Research, the scientists set up tests that could be used to determine from future findings whether this thing was natural or artificial. One obvious one is visible right here. We only see half a face. If this was intended to be a humanoid face and not an accident of nature, the other half should look more or less symmetric. It should complete the image. If this was an accident of nature, this would be mountains, valleys, craters, plains, anything but another half of a face. But there were 8 tests in all devised, and by the time I came on the scene, 5 of those tests had been passed, and later a 6th was passed. But I had proposed 2 tests to determine whether this was natural or artificial. And when I say passed, the other 6 tests were then indicating that this was an artificial object, not a natural one. I proposed 2 tests, and they were coming out with the opposite conclusion. I said, since this can't be seen from the ground as a face, it must have been, if it were an artificial object, it must have been intended to be seen from above, in which case you're talking about people on the home planet or people on an orbiting space station, beings, I should say, but clearly to be seen from above, and in that case you would want to build it on the equator so that it could be seen that way. And this object is far from the equator of Mars at 42 degrees north latitude. Moreover, if it was intended to be seen as a face, you wouldn't build it tipped over on its side or at some weird angle. You'd build it upright so that it would look like a face to any viewer looking down from above. And again, this is tipped at an angle of 35 degrees to vertical. Well, in an appearance on Art Bell's show with Richard Hoagland, we were talking about things related actually to the exploded planet hypothesis and origin of comets. And I mentioned the origin of Mars as a moon of planet V. And a listener wrote me an email and said, say, what about that face on Mars? Maybe that explosion, if that thing was built, maybe the explosion is what did in the builder's civilization. He said, and you mentioned a pole shift too that occurred at the same time. He said, well, tell me, where was the face on Mars before that pole shift? And I thought, well, that was an interesting question. As nearly as we can date that event, it was 3.2 million years ago. Where was the face on Mars before that all happened? So I got the coordinates out of the literature. Planetary geologist Peter Schultz, who has no connection with exploding planets or faces on Mars, had determined the previous position of the Martian pole before the major shift. And I got those coordinates, and I got the coordinates of this object, and using the coordinates of the pole, I drew in the old Martian equator. This object is within 1/10 of a degree of that line, even though the location of the equator is not as certain as 1/10 of a degree. So coincidence somewhat favors us, but the point is it's as close to the equator as we can tell from the accuracy of the data we have. And is it upright? You be the judge. It would look as though it was an upright face as seen from above. Well, here is a computer enhancement of the Viking image that was available after computer enhancement techniques were perfected in the mid-'80s. And we can see that while not a perfect mirror image, the mouth feature does go through, the nose feature does look as though it's at a higher elevation than the rest. There is another eye socket on the other side, and the enclosure is remarkably symmetric all the way around, the helmet-like feature as it's called. So the symmetry test was being passed also, and the two tests that I had proposed that indicated that it was a natural object because it wasn't built anyplace special and was built at an angle, were now suddenly shifting over into the artificial column as well, if we simply allowed for the fact that this might have been built before that cataclysm happened to Mars. So now we had all 8 tests that have been proposed by scientists coming out. This is an artificial object. Well, that's remarkable. Here are face-like objects seen here on Earth. Some are well known, some less well known. There are a great many of them. They have something in common. They are profile images or shadow images. They are either of this type, that they only look like a face when seen from one viewing angle, but if you go around front, you don't see anything that looks like a face at all. Same with this or this. This would be in the area of a trick of light and shadow. Any other time of day or viewing angle, you don't see it. Same thing down here with this. These are all two-dimensional face images, just as faces in clouds and faces in landscapes always are. As far as three-dimensional faces on this planet, the best example is these guys, Mount Rushmore. And their appearance as a face doesn't change when you view them at a different viewing angle. George Washington still looks like George. Although, of course, when we view at this angle, now we can only see one eye, nose, and part of the mouth. We're still able to recognize it as a face. Well, when NASA was tasked with imaging this object, because there was a lot of public interest, they assigned it to JPL that was operating the spacecraft. And JPL at first refused to take the image, but they were prompted with enough extra funds and bribery that they finally did take it. And they took it under very unfavorable lighting circumstances and a very unfavorable viewing angle. Basically, they were well off to one side of the face, so we were looking at the face from approximately the angle we see George here, and couldn't see across the nose ridge at all. But at least they got us a high-resolution image of it. Now, before I show you that image, let me say how, in scientific method, we judge these matters. Scientific method is the way scientists tell whether things are accidents or significant, whether things are artificial or natural, and so on. We use what's called the a priori principle, which basically states that the odds of something arising by chance are significant if calculated before any evidence of its existence is known. And the opposite of that is an a posteriori finding, which means that you don't predict the odds of something until after you've already found it. In that case, the odds are not significant at all. The calculated odds of something already found arising by chance apply only to the next example, not to the one already known. So, as applied to the face on Mars, here is the inset shows the Mars Global Surveyor spacecraft's first image returned to Earth as the spacecraft actually saw the face on Mars. And as I said, it's viewing from one side, so we can hardly see anything over the nose ridge, which is here in the image. But we see the eye socket on our side very large, and the mouth feature very prominently. And the lighting is coming at a low angle from under the chin. And you know how when you put a flashlight under a human face, under the chin, the face looks a little distorted by the lighting. But nonetheless, the main features, especially the symmetry of the mesa, are there. And more importantly, because it's high resolution, it gave us a chance to test the predictions that had been made in advance before anybody had this data, before anybody on Earth had this data, about what should or should not be seen if this was artificial versus natural. And the thinking was that all we could see in the Viking image was the impression of an eye, of a nose, and a mouth, and a symmetric mesa. But if somebody intended to portray a humanoid face, they would have probably, especially on this scale, 2 kilometers high, which is 100 times higher than the biggest faces on Mount Rushmore, by the way. They would have gone to a little more trouble than that, and probably they would have added secondary facial features, which are on all humanoid faces, such as eyebrows, irises, nostrils, lips, and so on. So predicted in advance that high-resolution image would show up, eyebrows, nostrils, irises, and lips, but that still isn't sufficient for the scientist, because in a noisy background, you can always pick and choose things that look like these things and just happen to fit your preconception of a face. So a second condition for it to pass this test is that there must not be any other objects except for the iris, which is a circular shape. There should be no similar features exist in the background that would allow us to pick and choose the ones that just fit our preconceptions. Then, if we see something that looks like an eyebrow that is about the right size, about the right shape, about the right location, about the right orientation, and there are no other objects that would pass in that way, that's significant. And so we have a number of these. These tests, each one has long odds against passing, anywhere from 10 to 1 up to 10,000 to 1. And the actual odds I will show on the next slide. This slide is the image that I just showed you as passed through 2 filters and averaged by the Jet Propulsion Laboratory and released to the press the same afternoon that image came down to Earth. And what's been done here, and you can go to this website and you'll see the original spacecraft image, you'll see the recipe they used to get this image, and you'll see this image. And the recipe said they put it through a high-pass filter to wipe out the high-frequency detail, low-frequency detail. They put it through a low-pass filter to wipe out the high-frequency detail. They averaged the two with the detail removed, and that's this. And then they said, look how flat and featureless this is. You'd be crazy to say that was a deliberate attempt to portray a face. And when pinned down later as to why they did this, they were very candid. They said, because we're certain that this is not anything but a geological feature, and therefore we are wasting public funds, and it is a slap at the integrity of the scientists to continue pressing NASA to take images such as this. And we object, and this is doing the public service by preventing further wasting of funds and scientists. Now, just to emphasize the point, they put this thing through a high-pass filter, and from Adobe Photoshop, here's the definition of what that does. It retains edge details where sharp color transitions occur and suppresses the rest of the image. The filter removes low-frequency detail on an image, useful for extracting line art and large black and white areas from the scanned image. Why would you want to put an image where detail was everything through a filter that removed the low-frequency detail, and then put it through a filter that removed the high-frequency detail, and then average those two? By contrast, the Society for Planetary Study Research engaged some scientists who were experts in image processing, and they said, well, we've got several views now between Viking, which saw the face about a dozen times, and the Mars Global Surveyor view. And so we are able to triangulate and know the three-dimensional structure of the face. So it said, put all this in a computer. The computer is not programmed with any knowledge of what this is. It's just points of light on images. But we told the computer to then take the three-dimensional information about the points of light and reconstruct what the image would look like if viewed from overhead and with high-angle lighting instead of viewed from the side at low-angle lighting as actually occurred. And let me enlarge that. All right, this is a negative of the actual spacecraft image, and the short animation I'm going to show is what the computer did to first just take this as an image of bits, not with respect to any content, and correct it for the lighting, which you'll see happen first very quickly, and then correct it for the orientation and show what the reconstructed object actually looked like. There's the lighting change, there's the orientation change. I contrast this with what JPL gave the media. The conclusions we draw, the independent scientists, not all of them agree, but a significant core of them do agree, is that the formal odds, multiplying all those improbabilities together, finding those artificial features in a face, and all having the correct size, shape, location, and orientation, and with no similar objects anywhere else on the mesa to pick and choose the ones that just happen to be right for a humanoid face. The formal odds against all those things happening by accident are 1,000 billion to 1. What we conclude is, we think conservatively, that the artificiality of the face on Cydonia, reinforced by this set of tests, in addition to the 8 earlier tests, which aren't even included in that probability calculation, is established beyond a reasonable doubt. Now, the importance of that is not so much that the face on Mars is artificial, as that by establishing the artificiality of any one thing on Mars, then that removes the idea that things on Mars can be artificial from the status of an extraordinary hypothesis to the preferred hypothesis if you find something else nearby that looks artificial too. If you have one thing that's surely artificial and there's something else nearby that's suspect, then you can consider all the hypotheses, but artificial then becomes the preferred hypothesis in many instances rather than an extraordinary one. So that's the importance of the formal odds on this one and why I devoted a little extra time to it. And we have Stephen Goldberg's advice too, which is well known to scientists, but not frequently followed. The consequences of a claim that something is true are entirely irrelevant to the issue of whether the claim is true. Now here's a low-resolution image with an interesting field of objects that all look sort of vaguely pyramidal in appearance, but at low resolution you can't really tell much. And here's a white strip that crossed one of these, and we see it at high resolution, and it looks very pyramidal. Well, if the one we got by chance at high resolution looks like this, we have to wonder about the others, which sort of tend to line up here, don't they, rather than be scattered about at random. So we, again, feel for exploration in the future. Wouldn't we love to have lots of rovers running around Mars and answering our questions? But our children will know the answers to a lot of these questions. Here is a very interesting crater, unlike any other seen in the solar system, because it is so flat-bottomed with such steep high walls and such a remarkably flat rim around it. And while it's not unusual for craters to have a central peak or other irregular feature near the center, here is a teardrop shape well off to the side, which is unprecedented, to be so regular and yet so displaced from the center. They say there's nothing like it anywhere in the solar system except its twin 20 kilometers to the south. The rim looks so flat in this image that you could visualize driving a bicycle around on it. Here is a crater with what looks like a geodesic dome in its interior, a couple hundred meters in diameter. Here are some what look like crystalline fractures, again suggesting artificial materials. Here are some odd, very unnatural looking shapes, an arrow, a rectangular shape with a circle and a stair-step shadow. Here are some white surface markings that don't look very random, and there are others of their kind. Here are some shapes, again, that defy normal geological processes that we're familiar with. We know how to make trenches, but not trenches in T-shapes by natural processes. And a crater wall that's this flat-bottomed and with walls that steep can't be made by impact, and certainly neither can this, because you can't excavate by impact. You make craters by impact through explosions. So they're always circular or very mildly elliptical, not that elongated and deep. Here are other objects that look artificial in their own way, something like highways or white marks that travel across the plains. There are many features of this type. Here's an area that has what look like pathways. This is very reminiscent of the roadways used by ancient civilizations as found by archaeologists and geologists on Earth. And they aren't random. They tend, wherever they intersect, there tend to be a lot more of these small square or rectangular boulder shapes, which are about the right size in many cases to be buildings. We'd love to see that at higher resolution. Here's a field of layers and layers of rectangular objects, bigger ones on smaller and smaller and smaller. Here is an interesting object that looks very much at high resolution like what might have been an abandoned quarry or a water reservoir because of there's even an absence of cratering on the berm and other features to suggest that it was carved. Here is a region of Mars that's pretty mountainous with valleys in between. We come to one valley and we look at that in high resolution, and we not only see some very bright objects that have more than natural reflectivity, but they tend to be rather linearly laid out and squarish. This is a possible remnant of something interesting. If it were on Earth, we'd be rushing there to look at the ruins of some ancient Indian civilization or whatever. Here's, again, a set of interesting objects, triangular in shape. Some think they aren't triangles at all. They're obelisks standing up and casting shadows. But is that any less anomalous? And they aren't random at all. As you can see, they tend to lie along arcs. There are lots of other similar features seen in other places on Mars. We don't know what to make of these, but we'd sure like to get a close-up look. Here's an interesting object. You don't often see hexagonal craters inside of other craters. And if this is seen in higher resolution as we did, we see that around it are these white bands between the outer crater and the inner crater, the row of white bands. We'll see more examples of those bands in a moment. And inside the hexagonal crater, it almost looks like the sculptor's inscription, doesn't it? Speaking of symbols, there are places on Mars where we see things of a definitely symbolic character, as here, and in the black markings here, which is again in the Cydonia area. Of course, if those really are symbols and not accidents of nature, then we are talking about, without any question, the activity of an intelligent civilization, though not necessarily an indigenous one, to Mars. There are other kinds of features too, and this begins a discussion of the features that have these white lines to them, the white bands. They tend to line other interesting features. This one lies along a feature that we call the seahorse. I'll show in a moment. This is another one that's specifically in the Cydonia area. Both of these are in Cydonia, but these features like this with the bands are seen over wide areas of Mars. Not all areas, but over areas that are spaced by as much as 1,000 kilometers. We discovered from the patterns of seeing many of them that they are actually mostly subterranean features, and we only see the white bands when something has washed away the topsoil and we see what's slightly below the surface. And there are other cases where there's been substantial erosion and we can see deeper below the surface, as in this area, with the left band seen in higher resolution over here, magnified view. Here we see crevices where the soil has been eroded away, and of course the soil is weakest where these tubes have occurred, and that's why it washes away preferentially there. And we see that the features that we have now come to nickname glassy tubes are present. They have junctures such as this. They go off in different directions, always toward interesting things. And they have the white bands, and the white bands wrap all the way around. You can possibly see that faintly here between the top bands, and on the underside you can see where the bands go all the way around and are seen faintly through them. So they are translucent as well as the bands wrapping all the way around. And down here, that's an image of this spot. That's a specular reflection of sunlight. And again, specular reflections don't occur off natural surfaces. They occur off glassy or metallic surfaces or plastic surfaces, suggesting, again, artificial materials. There are lots of these things. This one shows its very glassy character with shorter white bands with specular reflections. This one is on another plateau at Cydonia. We see a number of them here, seeing them close up here. We see them casting shadows into the ravine. So they are definitely high features well off the ground. They're not sand dunes, they're not lava tubes as has been proposed, and we'll see some of these features prove that can't be the case. Here's a Y branch, and here's again, these things often go off in different interesting directions. Here's places where the surface has been eroded away, and we can see a nest of these things beneath the surface in this area. Here we are back to Cydonia. There's the face again, and this is the fortress feature I mentioned earlier. I mentioned that these glassy tubes tend to join interesting places. Well, here's why I say that. Notice here in the In the fortress image, see that there's a little dark mark here, which is actually it looks like an excavation coming out of the fortress. Let me enlarge that briefly. All right, I wanted to do the enlargement on this, but my control isn't working at the moment. But I'll show the inset down here so you can see it. This is a very high resolution view of just this small portion right here. And we see that this is the shadowed edge of the triangular part of the fortress, what looks like the back wall right here and its shadow. And this is the dark object that seems to be coming out of it, and it's a glassy tube. But it disappears below the surface about so far out. Well, we now have infrared images of this area, and infrared can detect things just slightly below the surface. And with the infrared view, we've been able to trace where this tube goes. And it doesn't just go anywhere randomly. It comes out of the fortress and follows this path down right. It comes out of the middle of the fortress wall here, follows a path down to the middle of the mesa below the face. So it follows this path. And when we examine it with much higher resolution than you can see on this view, we can see that there is a fainter tracing of a tube that goes up and does the same thing to the face. So the mesas are joined by glassy tubes. Here is a low-resolution view of an interesting crater where there are a number of fissured cracks around it. One that seems to completely surround the crater, and one that's sort of coming by and sort of branches off to join the crack around the crater and then goes on its way down to the next interesting place. And here's where we have one of those that's a low-resolution view. Here's where we took the high-resolution strip image, so we only got this part of the view, and here's what it looks like, and it's clearly a junction of glassy tubes. So apparently, if these things follow the crevices, they just go in and circle the crater for whatever reason, and then they go on to other places in the distance. Always interesting places. A place where the surface has been well eroded away again, and we can see structures of glassy tubes. This one is especially interesting because look at this place. Here's a glassy tube, and here's a glassy tube. Here the white bands are going this way, east-west, and here they're going, or I should say north-south. Here they're going east-west. At this point, they're perpendicular, and we can see the cross-check pattern, one tube crossing the other, showing that they are translucent. You can see the one below the other. And certainly there are no way that sand dunes or lava tubes can be mutually perpendicular at the same place at the same time. Here is another case that is interesting to take a note of. This is an intact glassy tube showing very nicely the banded structure and the sort of membranes that join the bands, and the translucence you can see faintly through to the other side. And here's a large boulder that is rolled in and banged into the glassy tube and broken it. And here is the broken off portion of the tube. You can see it was severed here, and here's the broken off portion, and you can see the broken off portion of the bands are very spindly and very bony looking. And moreover, you can see that this broken portion of the tube has been flattened, and we can see both the under part of the bands and the over part of the bands equally bright. And there are twice as many of these bands for every one there is of these, of the intact circular tube where we can only see the underbands faintly through. And down here is another place where a boulder has damaged the same tube, and this section is completely flattened. So we get the double spacing and this bent appearance of the tubes that have been broken and flattened, and this appearance for the tubes that are still intact. Finally, we see, I'll just show these last examples. Perpendicular intersections is no problems, junctures, and yes, there are terminals for the tubes where lots of them seem to come in from different directions and join in one place. very reminiscent of some transportation systems on Earth. We don't know what the glassy tubes are, but they certainly are suggestive of artificial things in many ways, as shown in this artist's concept. This is not taken by an astronaut on the Martian surface, but this is what an artist's rendition of what perhaps someday soon we will see in pictures coming back from Mars. Whatever they are certain to be interesting indeed. Here's that seahorse feature I mentioned. There's a glassy tube running along its lower length. This is in a portion of Mars in the Cydonia region in which we see lots and lots and lots of shapes. There are so many shapes concentrated in that region that it's hard to ignore them all, even though we can't prove artificiality for any of them. But because there is a context for them and there are relationships among the shapes, and this provides evidence that these are artificial objects rather than objects seen in clouds. These things tend to cluster by type. This is a small animal of some sort, an aviary flying object of some sort, an aquatic object of some sort, and an insect object of some sort. What's mostly significant here is not the examples I'm showing you, but that like type of objects tend to cluster together. So the aquatics are one area, the insects in another, the mammals in another, and so on. So it's their relationship to one another that gives it away, that this has been designed, it's not an accident. Though you could argue that any one of them was an accident. Here's another example of a not very impressive object. This one's not at Cydonia, but this turned up in a high-resolution image, and someone said, well, gee, my artistic mind says that looks sort of like a puma. But it's not all that impressive, but we now know that we shouldn't dismiss these things out of hand. He said, well, I tell you what, either this is an accident of nature or it's a puma, another example of an artistic image on Mars. And he says, it's cut off here, so we don't see the hindquarters. If this is any kind of an animal, he says, don't take puma literally, but if this is any kind of an animal depiction, then it ought to have a hindquarters with a tail. And if it's not, it won't. So the scientists predicted that this would be seen someday when we got a high-resolution view of the hindquarters. Well, the Mars Express spacecraft came to the rescue, and even though it's not a high-resolution view, we have a low-resolution view there, and I'm going to try once more to magnify that. No, it's just not, my magnifier is not working. So I'm going to have to ask you to go by the view that we have there, or perhaps those of you in the front row can see it. But it shows very plainly in the Mars Express view that the animal has a tail and its hindquarters with its legs sticking out and its tail facing out, pretty much as predicted, except it has a typical feline kink in the tail in the rear quarters. But it's right size, shape, location, and orientation to be a tail. And this is, again, an example of an a priori prediction, the kind that scientists are supposed to pay attention to, whatever the outcome. If it fails, you dismiss it. If it passes, you must pay attention no matter what your biases are. And this is an a priori prediction of an artificial object where the test results said, yes, this is an artificial object. Here's an example of what I mean by clustering. This is a strip image in the Cydonia region, and this is what made us start to think about what's really going on here. This is that seahorse image I showed you, and it's sort of in a dark region as some of the other aquatic images are, and this is sort of like a fish-like image with a possible hermit crab shell there and so on. We began to think of this as the water area on Mars. And these look like possible underground sea bottom plant life and so on. And we said, well, all right, if that was so, what's right above that? And when we looked at this close up, The streak patterns here and the way they abruptly end at the bottom was very suggestive of a portrayal of a waterfall. And above that, we saw things that were suggestive of possible icebergs, possible mountains. That was all we had at that point in time, and we said, well, this is starting to look more and more as though it could be a possible coherent mosaic, a possible coherent painting on the surface of Mars. If that's so, before we find out what's there, we should predict what would be next. What would be above mountains or above the landscape? We said, well, the predictions we made were it would probably be a portrayal of clouds, which could look like a lot of things, so it probably wouldn't be very impressive. But maybe we'll get lucky and there'll be a plane or a spaceship in the sky or something like that. Well, again, I apologize that I can't show you the magnified view. Did we lose our image over there? Okay. What we actually saw in the top part of the image was a series of little white mounds all over the place, dotting what should have been the sky. And it's the only place on Mars or anywhere in the solar system where we've seen something on the ground that looks like a star map. And that wasn't what we predicted, but it sure does fit the scenario that this is a coherent mosaic with a theme to it. We see many patterns on the ground, some not so impressive, some more so. But we've now learned to start paying attention to them, even when they're as weak as this one. Because sometimes there is a lot of detail there, more than probably could occur by chance, and we're eventually going to have the chance to get both higher resolution and color for these images. That one may not be impressive, but this one has a reason to take it seriously. This is what's actually on Mars. This is an artistic enhancement. Anything with white lines or coloration added is artistically enhanced. But even on the actual image from Mars, we can see that there's actual hair on the image, eyes, a nose, a mouth, a definite outline of a face, of a body, and so on. Those lines are all there. They're not just imagination. And it looks like the portrayal of a humanoid child. Well, we've never seen one like that anywhere else in the solar system, but this one. Where is it? 2 kilometers north of the face on Mars. Again, relationships. Humanoid child next to a possible portrayal of a humanoid adult. Next to this guy. Here's another face profile. Because it's a profile, it's hard to prove artificiality, but it's in the Cydonia region too, artistically enhanced here. This one is far away from Cydonia, but we see that in this magnified view, it looks almost suggestive of Egyptian antiquities. And that theme also shows up in this one, which is nicknamed Nefertiti. Again, the actual image from Mars is here. It's impressive, not so much from what you see at a distance. I'm sure you can see that the outline shown by the artist is actually in the original. But when you study this close up, you are just blown away because this isn't just something that looks like an eye. This looks exactly like an eye with 7 eyelashes radially pointing from it. I tried to show those in a higher resolution view here. The artistically enhanced view shows that there's an iris with a pupil and the outline of an eye shape with actual eyelashes. And when we look at the view to see depth, the outline of the image follows the depth profiles too, so it actually is enhanced slightly above ground level. This is the last of the images, and it speaks for itself. This is on Mars. It's not on Earth. There are arguments about whether it portrays a male or a female, but it's a remarkable image. And we have to determine then what to make of what we're finding there and its significance. As I say, in some of these cases, by the most objective tests that scientists have that take all the biases of the individual out. We can prove that some of these objects are artificial. Others are almost certainly artificial by their interrelationships or the correlations they have with one another. And objects like this are just plain visually striking, but they're not random either. We're not seeing many grays or other types of aliens. We're seeing distinctly humanoid and terrestrial features, and why would that be? Well, let me end then by going down our hallway back to the real world, where we have nothing but the skeptical rest of the world and our own speculations. And the speculations that I'll offer are these. The face, and many like it, are hominid, not alien or animal, and the builder's civilization, if that argument about the Cydonia face is true, must have ended 3.2 million years ago, which is the same date when of the oldest fossils of our civilization found here on Earth. That compels the mind to wonder about a possible connection between their civilization ending and ours beginning at around the same time. Moreover, the planet explosion led to a massive flood. So this begs us to wonder if we aren't dealing with Cydonia being a sort of museum or theme park for visitors from the home world, now exploded, to go to their moon. Is that such a far-fetched idea? I throw out to you the thought that aren't we headed toward exactly the same thing? We have already achieved manned space flight to our moon. Someday soon there will be many activities going on there, and they will want to draw tourists. Will it be very long before we start building attractions on our moon? It's so suggestive of our most ancient human legends, the Garden of Eden, of Noah's Ark. Is it possible that there is an explanation for these that no one has yet had enough knowledge to come up with? And finally, the fact that mammalian biorhythms on Earth are very close to the length of the Martian day, closer to it than to the terrestrial day, also leads us to wonder. So I leave you with those thoughts and with your skeptical friends, and I offer you what I can, which is we have the whole presentation on a CD. We have my book, the book Pushing Gravity. We have another CD about all about gravity, and our quarterly meta-research bulletin. Thank you very much.